All right, we've got 160.1 people watching. That's pretty good. Guess we get started. First of all, thanks for popping in on such a rainy and gloomy Saturday. It's good to see you. Long time no talk at you. Totally my fault. Hectic times these are. The day job is cranked up to 11. And thanks to global warming, my kids are getting record levels of homework. These past few weeks, I've had more going on than Stacy's mom. I'll be doing some metal fab today. It is for the Maho, though it's not really a big deal, project-wise. Though we haven't had a video in a while, so let's not rush into things, all right? I am chipping away at this thing. It's slow going, though I'm close. Problem is I'm at that last 10% that takes 90% of the time. And I don't want to subject anyone to death by a million milling machine updates. Fret not. You can bet your bottom dollar I'll have a solid series finale for you. If this thing works, that is. Next video will likely be the AC servos and drives, how those are set up, tuning, that sort of thing. Lots of people have been asking, and it's not falling on deaf ears. Hard of hearing maybe, but not deaf. Yet. We might also have ourselves a bon voyage party for the CNC router. Not sure what's happening with this yet, but this town ain't big enough for 2 CNC machines. It's already started its downward spiral to CNC storage area. For today though, and believe me when I tell you I've given this a lot of thought, I should really get this computer off of the trash can and onto the mill. Plan A was to just get a rolling toolbox of some kind and use that. Put the computer on top and have all the everyday tooling right there at the ready. But that'd have to stay tethered to the mill. And well, I don't like that. For me anyway, it just seems like asking for trouble. So I'm going to make a swing arm flagpole kind of a swivel mount, like you usually see on these CNC machines and sort of like this thing had from the factory. I'll turn up and weld some hinges and attach it directly to the machine base. That gets everything up off the floor, which always helps to keep things clean, and marries the PC to the mill all in one package. I was just going to attach to this flange. I've got 2 inches here or so that I could bolt into. Everything below that is sort of the coolant tank. If I drill into that, I'd have a big mess down here in the shop. Then I started to worry all the weight of the support structure, the PC, me angrily pounding the keyboard trying to work through cam paths, could blow this wall out. I don't think that would happen, but just in case, I think I'm going to move up to the corner. I can attach the two perpendicular sides, brings my hinge a little more forward, but that should be fine. I can accommodate for that in the arm. While we're down here, if anyone's ever wondered where Maho used to install the speakers on their milling machines, it's right there by the coolant tank. Gave them a little more bass. Can any of you guess what these are? Correct? They're a bunch of parts. Crazy coincidence, they just happen to be the parts I need. Funny how life works sometimes, huh? To our misfortune, these also happen to be joyless parts. Parts that mentally beat you down before you even start. Bores, counter bores, press fits, running fits, bushings, flanges. Just a bunch of material removal that stands between me and my finished project. The kind of parts most people would hire an intern to do, and under the guise of teaching them the basics, set them off on their path to a broken spirit. And only once every last ounce of happiness has been squeezed from their soul, when their smile has faded and their complexion turned a pale gray, can they finally be called a machinist. Instead of putting us both through that torture, here's what I've opted to do. I've traveled ahead a few days through time to after future me finish these parts, and simply brought them back here. Now, before some of you get all bent out of shape, tell me that's stealing and immoral, keep in mind I'm doing both me's a favor here. In building this support now, future me will no longer have to suffer through making these parts. That's what we call in the trade the win-win paradox. Sure, I could have just waited and taken the finished support, but I thought I'd at least show you, dear viewers, some of the welding and assembly. There's a lot to keep in mind here. Lately, I've taken a liking to these big old 1/8-inch tungsten electrodes, 3 millimeters-ish. I already had the torch hardware, then bought 2 of these lanthanateds, the 2%. These are blue on the back. A 10-pack of these big boys is expensive. Initially bought them for some high-amp AC welding and just left the torch set up this way. I realize it's going to sound stupid out loud, but they hold their tip definition, the point, much better. I've got a 220 amp welder, and on paper anyway, 332nd electrodes can usually handle that. Granted, I don't weld all day, but for what I do, 332nds does pretty good. 1/8 just seems to do it better. And for lower amperage, I just grind them to scary sharp. But again, they're expensive. In fact, I've taken using a long back cap to keep from cutting them in half. I hate long back caps. I don't know why. But you always lose the last inch or 3/4 of a tungsten. Less than that and your collet won't hold it anymore. So if you cut them in 2 to use the shorter back cap, you lose twice as much. Also, if you like to dunk a lot into the weld puddle, you're sharpening more and they're bigger. I've gotten good enough where I only dunk every other weld bead, so I'm getting closer to breaking even. I'll be honest, not 100% sure where we left off, but here's the swing arm, outrigger, the hinge support. I have no idea what this thing is called. I dropped out of medical school before we got to the names part. In any case, the L-shaped arm I welded earlier. I went with L because it's one less than M. It saved me a little time. Hinge knuckle on one end takes these 2 bronze bushings. This is the part that pivots at the machine base. It's reinforced across the bottom and goes into a vertical metal tube that'll hold the sheet metal console. This is also reinforced at the bottom with a big steel slug just to keep this tube from maybe buckling. Frankly, just a cap would have probably been fine. The top end of this is still open. It just holds this steel slug. This fits inside the ID of the tubing. And during assembly, gets another bronze bushing and a bearing. While we're here, and I don't know if you can see it, the welds aren't exactly at 90 degrees. This corner is just a little bit closed, and this is just a little open, I guess, depending how you look at it. When this is installed, the vertical tube won't be exactly vertical. It'll have a bit of a lean in towards the machine, with the hope that once the console, PC, and all that junk gets installed on top, all that weight brings it close to vertical. That's not so much due to deflection in the steel, though there may be a smidge of that, but more for the slop in the hinged connections. There's going to be a little play there, because I want these to move. That'll cause the whole arm to hang outward a bit, and hopefully land vertical. Let's head over to the machine and see how this attaches. As I mentioned, I want to attach this to and have it hinge about sort of the front corner of the machine base. I was going to weld some more flat plate into the right shape to get around this front outside corner and contour around the step here at the coolant tank. When I realized I still have a lab grade reference plate that Mr. Pete lent me. So I welded 2 tabs to the outside to create a hinge point. These welds tied in pretty darn solid. I'm happy with those, but I may add another bead on top. I don't know, they're not really undercut, but given the load, I may just put another bead across the top on both tabs. Then it was a matter of drilling and tapping 2 holes in the base. I don't have the right length bolts, but these will do for now. And Mr. Pete's angle plate already had 2 tap holes. I can now use for jack screws to touch off on the recessed coolant tank. Again, I'll replace these with bolts of the right size. I may use grub screws here, and I can also use these to some extent to level the arm. I realize that looks a little Frankenstein's monster. I'm not going to push the bushings in just yet. Before I do the final assembly, I want to get the right fasteners, maybe add some more weld to the angle plate, and get this thing cleaned, primed, and painted. I must admit, me and this 3D printer have really been getting along. Oh, nuts. I knew I was going to forget something. I always forget that one thing. This was supposed to have a tube across the front, sort of like a handlebar, a grab bar. I guess now it's a bolt-on upgrade. If the viewfinder on the camera is any judge, this thing probably looks huge right now, bigger than the milling machine. It does have some presence, but it's probably not as bad as it's coming across. For reference, that's maybe a 19-inch monitor, my trackball, iMach MPG, and my 40 centimeter long hands. Truth be told, I'm not as happy with this thing as the excitement in my voice might suggest. While building this, everything seemed so nice and overkill. Now that it's on the mill, I don't know, it looks a bit spindly. Mechanically, it turned out fine. The hinges move great. It's level and plumb and stays where I leave it. Unfortunately, it is a little vibratey. I think that's coming from the sheet metal at the top. I could tighten the lower knuckle a bit more, but I'm a little worried what vibrations during milling might look like here. I fear there might be that one spindle speed that could get this console going like the Tacoma Narrows Bridge. I suppose I could always add a single swivel caster at the bottom there. The reason you only saw one bearing in this thing is very scientific. I only had one. In something like this, of this size, bearings and bronze bushings are a little overkill. Plastic would have been fine. In fact, lined bearings would have probably been cheapest. Real thin, light, buy them off the shelf, cheap as dirt, push them in, good to go. But I added a ball bearing because I wanted the first hinge, the one we're looking at, to preferentially move first. Like I wanted the top to easily rotate, but then have to sort of pull the whole swing arm to move the whole thing. Roller bearings usually have less stiction, for lack of a better word. They'll start moving before plain bearings do. Sorry, I had to get a chair. I'm too old to be squatting down for more than 20 seconds. You might also notice the bottom isn't painted. I have vague plans to add some small storage down here, maybe. And I'll need to shoot some small welds up in here. Plus, I have plenty more sheet metal to do, so I can just paint it then. And since we're talking shop, I really should add some kind of an e-stop or limit switch to that bottom hinge. The table on this mill, the x-axis, moves left and right. And although the swing arm is designed to be outside of that maximum range, there is the potential, mostly if I put the mill in horizontal mode, where the console can be over just enough and the table come up high enough to potentially tear this arm right off of the machine. That's not usually a problem on newer equipment, newer machines, mostly because the entire machine is an enclosure and the console is quite far away. But also on modern milling machines, I think the tendency is to have the head move up and down instead of the table move up and down for the Z-axis. And to make this swing arm accommodate all possible geometries of this machine, well, it would have just gotten too awkward, too big. From the keyboard, I would have needed binoculars to see what was going on at the vise. Again, chances are slim, which probably means it'll happen tomorrow, which is why I think it would be smart to add some kind of a limit switch down at the bottom that ensures I'm out of those positions whenever the machine is running. And that's pretty much all I've got on the computer stand. In fact, that was probably 20 minutes more than I expected. But if none of you are in any particular hurry, let's talk about something else. I've been getting some concerned comments about this becoming a CNC channel. I can see how you might come to that conclusion, since this mill has completely commandeered the garage. It's a big project and needs a lot of space. But my plans for this machine might not be what you'd expect. Not to mention there are way better CNC channels out there I couldn't and wouldn't want to compete with. On top of that, you're not the boss of me. That's my wife's job. If all goes well, this, ideally for me, will be what I call a manual CNC mill. Or wait, CMC. Computer-mediated control. If I can figure out how to wire this stuff, I plan to have independent MPGs for each axis. Basically a milling machine with power steering. I know, you can already do that with a single MPG. But independent electronic hand wheels should give this more of that old-timey manual user experience. I also plan to add more manual screens to Mach 4. Manual screens tailored to the style of machining that I do. Something a little bit more than just facing or pocketing operations. Conversational style CNC without the conversation. Of course, I'll be happy to share those if I make it that far. Yes, CNC machining has its place. Arguably a very big place. And this mill will retain that capability. 2, 3, 4, all the axes. There's just some stuff you can't or really wouldn't want to do manually. And then there's me. Sure, CNC opens some new doors, but probably 80% of what I do, manual, is just frankly faster. By the time you CAD and CAM your part, set up tools and offsets and all that stuff, I'd already have scrapped my first part and be most of the way through the second. But I only make onesie-twosies, or am machining parts not from stock material. They don't start off square or round necessarily. Good luck getting that into CAD. Of course, if I've got a lot to do, or drill 1,000 holes, finish a hole too big for my boring heads, or cut funny shapes, well, that's a no-brainer. I didn't mean to confuse any issues here. Don't get me wrong, there's nothing you can't do on a CNC mill you could on a manual. Wait, did I say that right? If the part fits in the capacity of the machine, a mill is a mill, CNC or otherwise. What I'm getting at is gray area, user interaction, experience, and workflow maybe. With any luck, it'll become clearer as this whole thing wraps up. Anyway, that's it. I've hit my contractually obligated 30 minutes. I think we're done here. As always, I appreciate the company and thanks for watching. Are there any theologists watching that can tell me why spilled paint bonds atomically with anything and everything it touches and will peel off like a latex glove from what I'm actually trying to paint?